I was finished this, I assume worksheet 3 is like homework, so could I just rework it on our worksheet, or do you want me to do like worksheet 4?
You can do worksheet 4, or if I have another review I printed out, I think it's nice to you.
Okay.
You can flip the clues, but I'll cross off the ones you don't do. You just need to your practice. Mhm. We'll start in a few minutes. Yeah, we're just looking over your notes. A few minutes, we'll start and we'll do worksheet 3. All right, everybody good with the rules? Okay, so I want you to put everything away, no calculator. I also want you to tear off worksheet 3 so that you're only having worksheet 3 on your desk. And number 2 is going to be log differentiation. Okay, tear off worksheet 3, put everything else off your desk. Go ahead and get started. Okay, about 15 more minutes. Okay, 10 minutes. Yep. And if you feel like you finished, you can go ahead and take out your key and start grading yourself. But otherwise, why don't you guys keep working if you're not quite finished yet? Oh, you said what? You have simplified. Well, that's simplified also for credit. It's always
Okay, so it's like I was getting more left originally left like you guys, and it's just like the numerator part.
Yeah.
And right here, like it's like this is a 10 because I have 2 5s. Yeah, of course, like it's just. Oh, I'm doing the wrong one. Never mind.
Yeah, also it's
Okay, perfect. Yeah.
Okay, so hopefully you guys all had a chance to go through the majority of the quiz. Um, I think it's nice to have this chance where you can try each of the problems on your own to see where you really stand, or do you know the content as well as you think you do, and this either confirms it or it gives you some idea. Okay, I need to um, review this content or this particular concept a little bit more. So let me just highlight the worksheet as we go through, and for worksheet 3. So anytime we see a natural log problem, we always want to explore that chance of expanding. So we first want to rewrite that radical form in rational exponent so that comes out as 7/5. Remember, the number to the right is always up in the numerator of the exponent, and the number to the left above the roots is always in the denominator of your rational exponent. So now I'll bring the 7/5 down. We can go through a quotient property, natural log of A minus natural log of B, make sure that 7/5 gets distributed to both those terms. And now we do U prime over U for each of the terms. So e to the 5x becomes e to the 5x times 5, all over e to the 5x. Now, if you leave your answer unsimplified, I'll still give you full credit. So you don't have to simplify your answers all the way. But on my key, I did work it to a relatively simplified version of the answer. Number 2, the direction was log differentiation. So we want to make sure, first though, let's rewrite it as rational exponents. So the x is to the right of the parentheses that goes in the numerator of your exponent. There is a root here. There's a hidden 2, right? Anytime you see a square root with no number, that's understood that there's a 2 in the denominator of your rational exponent. This is x over 2. Notice that fraction has a constant as one of the sides. So there's no need for quotient rule here. We can just think of that as 1/2 x, right? And 1/2 x should be an easy power rule. But we know that this is a log differentiation problem. So we take the natural log of both sides. Then we can bring that 1/2 x down. And remember, with this process, you're always going to be expecting, if you're starting with a variable raised to a variable, and you can bring that variable down, it's always going to turn to a variable times a variable. And you're always expecting product rule to have to come out of that. So 1 over y dy dx, f prime g plus f g prime, and the g prime, we got to go through the derivative for each of these individual terms and put them up in the numerator. Finally, bring that y over to the right side, replace the y back in terms of the original function. And again, you don't have to have your answer simplified. Okay, number 3, we know we can start off our table this way. If we're looking for g prime of 9, we can fill it up to this point without knowing the rest of the problem. So whatever number they give you is always the y value of the function that you're working on. So f of 2 equals 9 is going to be the order pair that fits. So there's a 2, 9 here, which means there must be a 9, 2. If I can find f prime of 2, then that slope will lead me to g prime of 9. So f prime of 2 ends up being -3, because that's what's given to us in the values here. And then if the slope is -3, we know the slope on the g side must be the reciprocal, so -1/3. Same thing with 4. Set up your table. You know that the -11 given to you is really the y value of your function. So replace -11 in for the y, bring everything over to one side. Solve for x. X ends up being -3 because we tested 0, 0 doesn't work. Then we try 1, 1 doesn't work. Then try -1. Keep going back and forth until eventually you're going to get to an integer value that does work. We end up with -3. So there must be an order pair -3, -11 on the function, and then inverse must be -11, -3. If I can find the slope of the f graph at -3, I can get to the slope of the inverse at -11. So find f prime, plug -3 in, we get 25. So the answer must be 1/25. All right, number 5 is a log problem. This is not natural log. This is log base 10. But we're going to begin the problem like as if it was natural log, right? So we're going to expand out as much as we can. And once we have expanded out using quotient property and then power property, we can then go through u prime over u. But this is base 10, so there's a little bit of additional conversion that needs to happen. So there's a 1/natural log of 10 that needs to sit in front, as well as the coefficient that's part of the problem. Okay. Again, answer unsimplified will earn you full credit as well. It's just if your answer has a negative exponent, I do want you to push that negative exponent to the other side. Okay, next page, number 6. We should recognize this as product rule here. So f prime g plus f g prime. And e to the u, which is e to the u times u prime. Number 7, again, there's an instruction to use log differentiation. So we take the natural log of both sides, expand out as much as we can on the right side using quotient and power property, and then bring all the exponents down in front, and then u prime over u for each of them, and then 1/y dy dx for that left side, a little bit of implicit, bring the y over to the right side, place the y in terms of x. Number 8, a couple things that needs to happen. We have to go through quotient and quotient property here to get that expanded out. We have to go through product rule. And then there's implicit as well. We have 3 y variables. We should be expecting 3 dy dx's to come out. So we expand natural log of a over b is natural log of a minus natural log of b, u prime over u for both of them. And then there's a negative xy here. So I put a parentheses around the xy as a reminder that the negative will distribute at the end of product rule. So f prime g plus f g prime. And then careful y becomes 1 dy dx. I think having that 1 is really helpful. Later on, when you factor out the dy dx, having that 1 reminds you, oh, there's a placeholder. I can't just let that entire term disappear. And 12 goes to 0. Okay. Add and subtract so that your dy dx terms can be on the same side. Your non-dy dx terms on the other side. Factor out your dy dx and then divide over. Okay, finally, number 9, Cash-line equation. So there is product rule required. There's a to the u rule as well. So we need to recognize that. So natural log of a times a to the u times u prime. Once we get inside product rule, replace all your x's with 2 to get your slope. Then once you have your slope, take your order pair and slope, point slope form. All right, so hopefully after this exercise, you can pinpoint where you need to spend more time on and also where you feel comfortable. Okay, so tomorrow, I'll have a morning help session at 7:30 going over worksheet 4. And then, yeah, in class, you'll take a quiz very much like this, no calculator. So, yeah, let me know if you have any questions. All right, come get your phones. Yeah. This is a worksheet that I pulled from my website, so you can skip all the if you want. You want additional new ones, right? You can skip all the ones that it's just expanding, finding the numbers. Skip that as well. Yeah, there we go. The keys are attached. Okay.
I will not be here tomorrow, so I'm going to stay from week, so I can take it on Monday.
Okay. When do you want to take Monday?
Do you have this? I can do honestly any time in the morning because I take my sister to school.
Okay. Yeah, I'm free anytime too. Just give me a time, so I just have.
Okay. Yes, I
What's do you know right now, or you want to wait?
fifth period lunch.
Okay.
After fifth.
Okay.
Or
During
during
fifth?
fifth.
Sure. Yeah. I'll put it down.
I won't be here tomorrow either, but
Okay.
that's can she think I take it before school on today?
17 or 7. Yeah, 17, 7:30.
Okay.
Yeah. Get that. Okay. I thought this was just like because it used to.
Uh-huh. Great. Thank you.
I wouldn't.
And then just seeing there.
No, yeah, I got it. Yeah, thank you.
Already.
I know.
I will leave. I'm still for the. Very easy to get it done. But like going, it's a kind of, but I need some texting and